Problem number 22 first. 22. 22 is x plus 2y equals 1, and 5x minus 4y is equal to negative 23. So, those are our two equations so far. Now, if we're going to do this by the calculator, we need to first turn it into a matrix. So the top would be 1, 2, 1. The bottom would be 1. So we'd only include z if one of the equations had z. So if it shows up in one, it needs to show up in all. So if it had been, say, x plus 2z equals 1, and 5x plus, or 5x minus 4y equals negative 23, since one of them had z, all of them will need z. Yep. Since z is not listed in either one, we don't need it, because we're just solving x and y. Now, we can grab the calculator, say second matrix, and go over to edit. Now this is a 2 by 3. 2 equations, 2 variables, and a number. Top one is 1, 2, 1. And the bottom one is 5, negative 4, negative 23. 5, negative 4, negative 23. Second, quit. Second matrix. We're going to go over one and find RREF. We want reduced row echelon form. Second, next to second mode. Go over one to math.
And then the
RREF. Hit enter. And then second matrix, we want A. Enter. So 1, 0, negative 3, 0, 1, 2. So really the top number is going to be x, next number is y. And if we had x, y, z, top is x, second's y, bottom z. So negative 3, 2 is our final answer. Now if we did this by hand, we can do it by elimination. To do that, we want one of the two variables to have the same number in front. Now, it doesn't matter which one we do. If we want to eliminate y first or x first, doesn't really matter. I'll do y. Now, since the other one has 4y and our top one has 2y, I need to multiply it by 2. So the left-hand side, 2 times x is going to be 2x. 2 times 2y is going to be plus 4y is equal to 2. Now at this point we're going to add, and the reason we're adding is 4y plus negative 4y is 0. 2x plus 5x is 7x. 2 plus negative 23 is negative 21. Divide by 7, telling us x is, lo and behold, negative 3 like we got before. Now we can take this and plug it back in. We can take the original top equation, x, so negative 3, plus 2y is equal to 1. So negative 3 plus 2y is 1. We'd add 3 to both sides, telling us 2y is equal to 4. Divide by 2, telling us y is equal to 2. And that's it. Negative 3, 2. Questions on that there?
But are all those that we could just put together?
Yes, the only ones that will need a little bit more is when we have two equations with x, y, z. Our answer is going to be in terms of z for the most part, instead of a set point. And if it is infinitely many, most likely that's going to be our 3 variable, 3 equations. We'll have that. 1.4. 7.4 is partial fraction decomposition. This is one of the sections I do like. I do like doing partial fraction decomposition. It is very much a puzzle. Now, the whole thing with partial fraction decomposition is we're going to be given a fraction, given a rational expression, and we want to break it up into its parts. It's the partial fraction, the parts that make it up. So what would be the two expressions that we would add together to get our starting amount? So if we started out with 7 plus, or x plus 7 over x squared minus x minus 6, the partial fraction decomposition would be 2 over x minus 3 plus negative 1 over x plus 2. We're breaking it back apart into its fractions. There's two parts. Each fraction on the right side of the equation is a partial fraction, and together they make up the partial fraction decomposition of the left. So you do have this here, divide when improper. If the degree of the top is bigger than the degree of the bottom, we do have to divide so that it is so that the degree of the top is less than the degree of the bottom. Completely factor the denominator into factors of the form px plus q to the m and ax squared plus bx plus c to the n. And factor it as far as possible, and then rewrite it as a list of the factors, linear factors. And again, what's on top is going to be 1 less than the degree of what's inside. Even if we have a set of parentheses squared, if what's inside is just x, we don't have x squared, x cubed, on top is just going to be a, b, c. If on bottom is a quadratic, what's above it, it's going to be linear, bx plus c. If it's cubic, it's going to be a quadratic. It's going to be 1 less than. And simplify from there. So the following example, we're going to look at this here. So we want to write the partial fraction decomposition of x plus 7 over x squared minus x minus 6. Okay. X plus 7. First thing we need to do is factor the denominator.
I need sophomores with the last names whose letters start with M through Z to go to the library.
Okay. So we're going to factor the denominator, x squared minus x minus 6. Now this here is going to factor 2, x minus 3 times x plus 2. We factor the bottom as far as it'll go. Okay? Now we're going to list out all the factors and each denominator as a denominator of its own. So x minus 3 is one of the factors on bottom, yes? Okay. Now we only have one of them. If it had x minus 3 to the second, we'd list it as x minus 3, then x minus 3 squared. If it was, say, to the third, we'd have x minus 3 in the first one, second one would be x minus 3 squared, third one would be x minus 3 to the third. If it was cubed, we'd have it to the first, we'd then have it to the second, and then we'd have it to the third if we had a power there. We keep listing it out until that power reaches the number that's underneath. But here, it's just to the what? First. Since it's just to the first power, bless you, we just list it once. Okay? What's the other factor? We list it under the other one. Only have two factors at all. We have this here. The degree of the bottom is what? 1. X plus 2, x minus 3. X is the first power, yes? So that means the degree of on top is going to be 0. There is no variable x that's going to be listed on top. So it's just going to be A and then B. We always go in alphabetical order. If we did have an x, it'd be AX plus B. Then BX plus C. We just take the next letter after it. Questions on how we set this up? We good with setup so far, yes? What we'll do next is multiply everything by the bottom of this fraction on the left. We're going to multiply through by x minus 3 times x plus 2. Now the one on the left, everything's going to cancel, leaving us with x plus 7. That's all we got. On the right, we're going to have a times, well, the x minus 3 is going to cancel with the x minus 3, telling us that we have a times x plus 2, plus the b, the x plus 2 and x plus 2 is going to cancel, leaving us with b times x minus 3. Questions on this so far? Now we do need to simplify a little bit here. We're going to distribute a. A times x is ax. A times 2 is plus 2a. B times x is bx. A times negative 3 is negative 3b. Questions on any of this so far? I'm going to rewrite the right-hand side a little bit. X plus 7. So the two terms that have x, we're going to put them together next to each other. Our terms without x, we'll put them next to each other. X plus 7 is equal to ax plus bx plus 2a minus 3b. Now when we combine like terms, they have to be the same. And these are going to be equal. Well, our ax plus bx should match up with our x, yes? And our 2a minus 3b will match up with our 7. So really, we're saying that x is going to equal our ax plus bx. Whatever a and b, ax plus bx, those values of a and b should add together to give us x. The same is true for our 7 should equal our 2a minus 3b. Because whatever the value of a and b are, well, 2 times a minus 3 times b should give us 7. And ax plus bx should give us x. Well, let's make the left side a little bit nicer. Because we know x is already in common across the thing, yes? Really what we're saying is what? That a plus b should be 1, 1x, 1. That our a value, our coefficients a plus b should give us 1. Questions on this here? We have a system. We have a system of equation. Now we just need to solve for the value of a and b. Two ways we can go about it. One is I get either the a's to be the same or b's to be the same. So I'll rewrite this down here. Equals 2a minus 3b. I'll let y'all pick. Do we want to eliminate a or b first? B. So for eliminating b first, I'll write this a little bit down below. We need to multiply this whole equation by what? Negative 3 or 3, either one. I'm just going to multiply with 3. 3 times a is 3a plus 3b. Giving us 3 is equal to 3a plus 3b. Now the only difference between multiplying by 3 and negative 3 is the operation we do to cancel them out. Because if we did negative 3, we'd have negative 3b and negative 3b, which we would need to subtract. Since the signs are opposite, we can add, because negative 3 plus 3 is 0. 3 plus 7 is 10. 2a plus 3a is 5a. To get a by itself, we would what? Divide by 5. telling us A is 2. Questions on this here? To find B, we need to use one of our previous equations. Well, 1 is equal to A plus B. Well, what's A? 2. B is equal to -1. Questions on this here? All right, let's go back to the top. So what we had was this here. A over x minus 3 plus b over x plus 2. So we found A to be what? 2, and B to be -1. That right there is the partial fraction decomposition. Now there are several steps, or a good number of steps involved, but the overall math of what we're doing, there's not a lot to it. It's just a big old puzzle. Because we're trying to find out what A and B are, what those values are, and plug them back in. And we're done. Questions on this here? So this here, they set it up. Factored and multiplied through. They said let B be -2, so they were trying to figure out what's going to make that set of parentheses be 0. -2, so it gave us 5 is equal to A times 0 plus B times -5. 5 is equal to -5B. B is -1. And then they did the same thing for the other side. Telling us that 2 over x minus 3 is equal to -1 over x plus 2. This procedure used to solve for constants in example 1 works well when the factors of the denominator are linear. However, when the denominators contain irreducible quadratic factors, you should use a different procedure, which involves writing and solving the systems. Linear factors, for the linear factors, use coefficients in step 1 and solve for this here. Keep in mind, in proper rational expressions, you must divide the first before doing the composition. So that's like this one here. But I'm going to skip it for now. We're going to come back to it. What I want to look at is this one here first. Now for this one here, the degree of the top is 2, because the biggest exponent attached to a variable is 2. The degree at the bottom is 3, because the biggest exponent attached to a variable is 3. Now we don't factor the top, but we do want to factor the denominator as far as possible. X cubed plus 4x has the greatest common factor of x, and we can factor it out first. And what that's going to leave us with is x times x squared plus 4. X squared plus 4 is as factored as it gets. We do have two perfect squares, but they're being added together. It's a sum of perfect squares, not a difference. If it was a difference, we could factor it. So here we're going to leave it as x squared plus 4. So now we can start writing the right-hand side, this breakdown. We'll start with our terms that are outside the parentheses, so we'd have x. There is no other power, so it'd just be x. If it was, say, x squared, we'd have x. For the first fraction's denominator, second one would be x squared. We just keep taking those terms and putting them to a power up to the max 1. Now our other factor was x squared plus 4. And since it's to the first, we just have x squared plus 4. If it had been, say, squared, we'd have x squared plus 4 to the first, plus, and then the next fraction's denominator would be x squared plus 4 squared, cubed, and going up. Okay. Questions on how we set these two fractions denominators up? We good with that there. Now, since the first denominator is just x, degree 1, the top is going to be a. Now, the next denominator is x squared. The degree is 2, so the degree on top needs to be 1. So our next letter is going to be b, but we're going to have bx plus c. We're going to have a linear term, b to the x plus our constant term. If it was a cubic, it was x cubed plus 4. On top, we'd have ax squared plus bx plus c. Questions on this here? Questions on how we got this set up? Now, at this point here, we're going to do the same thing we did on the last one. We're going to multiply this by the denominator of our fraction. Now, the left-hand side of this equation is going to cancel out completely, telling us that we have 3x squared plus 4x plus 4 is equal to, on the right-hand side, the x and x are going to cancel, telling us that we have a times x squared plus 4 plus bx plus c. Well, the bx plus c, the x squared plus 4 on top and bottom will cancel, leaving us with just x. And when we multiply this through, 3x squared plus 4x plus 4 is going to equal a times x squared is ax squared. A times 4 is going to be plus 4a. X times bx is going to be plus bx squared. X times c is going to be plus cx. Now again, just like the last one, I'm going to rewrite the right-hand side to just have our like terms next to each other. So ax squared plus bx squared. The only x term is cx, so we'll put it next, plus 4a. Well, our 3x squared, we should get it from our ax squared plus bx. So we could say 3x squared is equal to ax squared plus bx squared. Or really that what? 3 is equal to a plus b. Our next one's 4x. Well, 4x should equal cx, or really what? 4 is equal to c. Do I need to do anything else to find c? No, it solved itself. And the last piece is our constant term 4 is equal to A is 1, C is 4. What is the only thing we're missing? B. Because we can come back over here and say that 1 plus B is 3. A is 1, B is 2, C is 4. So that means for us here, we have 1 over x plus b we said was 2, yes? So 2x plus 4 over x squared plus 4. That's it. So not always will we end up with a system of equation. Sometimes we will, sometimes we won't. But I would always break it down, see what we know, plug in and solve for what we've done. Because here, even if we didn't find C, there's a good chance that we could find B and then use it to find C, or use its parts. Questions on this here? 2x squared minus 5, degree of the top is 2. The degree of the bottom is 3. X squared plus x has the greatest common factor of x. So just like the last one, we'd have x under the first, x squared plus 1 under the second. Our letters on top is going to be a, and then the second one's going to be bx plus c. Yes. Yes. And just like before, we're going to multiply everything by x and x squared plus 1. Left side, everything's going to cancel, leaving us with 2x squared minus 5 is equal to, in the middle, x and x is going to cancel, leaving us with a times x squared plus 1. That's over here, x squared plus 1 is going to cancel, leaving us with plus bx plus c times our x. Distribute through. Now we could rearrange it. We don't necessarily have to, because my 2x squared is going to be the combination of ax squared and bx squared, yes? Really, we're looking at the numbers. We're just saying what? 2 should equal a plus b. Do we have an x term on the left-hand side? Well, no, it's not one written, so it's understood to be 0. If a term's not there, it's going to be 0x. So 0 would connect to our c. Cx are just c, so in our case here, c is 0. We know. Now, negative 5 is our term without x, yes?
Yeah. Oh, so that would be...
So,
okay,
A.
I forgot that you didn't have it written like I had it written. Like
Yep. Yeah. And that's sometimes nice about rewriting is we can match it up. But so far we have C as 0 and A is negative 5. Now we can come back over here and say that 2 is equal to negative 5 plus B. Add 5 to both sides, so B is 7. So for us here, A is negative 5, so we have negative 5 over x plus 7x over x squared plus 1. Well, it'd really be 7x plus 0. No reason to write plus 0. We can just say 7x. And there's nothing restricting us on making or having the value b be 0. Because we could have 0x plus 7, or just 7 over our x squared plus 1. You're all starting to see how these work. Maybe, maybe not. But hopefully y'all can see why these are kind of fun, in that it's just a big puzzle. It's setting it up. Setup's not bad. We just got to factor. And then see, how does A, B, and C, how do these line up with each other, solve for the missing parts? We'll continue this tomorrow.